you want to put your coffee there?
Probably.
All right, hope you guys can hear me. All right, the next speaker is coming all the way from Edmonton, so give it up for him. So the speaker's name is Amir. He has built a career focused on architecting, developing, and maintaining ETL pipelines for various company initiatives. He was previously a data engineer at AlphaLayer, which is a Canadian fintech company utilizing machine learning to generate returns from financial markets. During his free time, Amir can be found mountain biking, climbing, or playing video games with his friends. So I'll give the stage to Amir. Thank you.
Hey everyone. So yeah, I haven't presented in front of people since like undergrad, like 7 years ago. So it's gonna be fun. Yeah. So thank you for being here. My name's Amir. And let me start my presentation. So I'll be talking about data engineering, building skills in data engineering, and what it is to, I guess, be a data engineer. We'll start off with a bit of an introduction. Then we're going to kind of switch over to technologies and adopting new technologies into your stack as a data engineer. Then kind of pivot over to developing data pipelines, followed by kind of starting a career in data engineering if you're curious about that. So introduction. I'm Amir. That's my cat. Can't really think of a picture, but yeah, she kind of takes the attention there. Currently, I work at a company called Hydra. It's just a small kind of startup that's kind of implementing a Postgres extension that kind of allows you to write Postgres for various data warehouses and databases. Won't dive into it too much right now, but that's currently what I'm doing right now. Prior to that, I was a data engineer at AlphaLayer, where I was kind of tasked with developing the entirety of the data engineering infrastructure for that company, utilizing Prefect, Azure, Snowflake, so forth and so on. Prior to that, spent a little bit of time as a machine learning intern at a company called Astronomer, which is kind of the de facto Apache Airflow company that provides a cloud solution for that tool. We'll dive into that later on if you guys want. And prior to that, spent about 5 years in the investment finance industry, mix of kind of public, private equity trading, research, cash flows, a bunch of stuff. But yeah, currently a master's of science student studying data science. Mountain biker, that's like, I guess, the only kind of trait I can think of there that I can throw onto the PowerPoint. So what is data engineering? So, bunch of things out there that kind of explain it. I just threw this into chat GPT and just asked it what data engineering was and just plagiarized the entire kind of spiel and threw it here. So shout out to that. So data engineering is the process of designing, building, and maintaining the infrastructure and systems that enable organizations to collect, store, process, analyze large amounts of data. Kind of like a mix of like computer science, data analytics, and so forth. You're moving data from point A to point B to point C, transforming it along the way, and kind of priming it for further analysis by data analysts, data scientists, machine learning developers, so forth and so on. So to kind of pivot into here, so I'll be talking about what it is to adopt a new technology into your stack as a data engineer, kind of applicable, I guess, to other areas of computer science. So kind of focusing on immutability versus transitory. It's a technology's lifelong mission towards avoiding obscurity. So a bunch of words there. What does this all mean? So a technology can be classified as immutable by being something that lasts. SQL, Python. You have the big three cloud services: AWS, Azure, Google. These are tools, technologies that kind of here reliant on by many organizations are kind of here to stay. Transitory can kind of be tools that come and go, concepts that come and go, things that don't really last the multitude of time, I guess. So this is from 2012. And it's the big data landscape then. So many of these tools here may seem familiar. Many of them also may not. I wouldn't be surprised if half these tools don't really exist anymore due to that kind of transitory landscape where these tools didn't really withstand the test of time. This is the landscape as of 2021. It's grown quite a bit. Don't really expect you guys to actually see any of these. It's a lot. It kind of bears the question, how many of those tools that existed in 2012 are present in this chart? And how many of these tools from 2021 will be present 9, 10 years down the line? So it kind of bears the questions, how do you help kind of avoid that potential risk of a tool that you're using becoming obsolete? There really is no right answer, but the best thing you can do is kind of doing some due diligence and assessing a tool prior to adopting it into your stack. So what are the underpinnings of a technology's longevity? So community support, I would say, is probably the most important. And again, this is also relatively subjective. People may have differing opinions. But what is community support? A tool is nothing without its community, whether it's open source, whether it's being adopted left and right by individuals. In turn, if a tool is no longer kind of being supported or used by the community, it's not really, existing, I guess, in a sense. What are the underpinnings of that? What makes a tool last longer within the community? And how do you kind of promote utilization? Well, flexibility is a big thing. I wish I actually had my notes present here, but I wasn't able to kind of find them. But flexibility, within a tool is kind of able to, adapt, take on more loads, able to kind of focus on, I guess the example here could be like AWS, a cloud solution that has many different kind of aspects to it. Whether you're using RDS, whether you're using S3 storage, many different kind of offerings. With that, AWS is able to kind of be flexible and kind of take on new types of solutions as it kind of, its life kind of goes on. It's a relatively ambiguous thing there. A tool's longevity is also kind of tied into its aspect of being able to be innovative. How much of a disturbance does this tool make? A great example here is kind of Databricks. Everyone kind of talks about Databricks. It's kind of like Jupyter Notebook mixed with cloud solution, mixed with being able to natively switch between Python, Spark or Scala, SQL, so forth and so on. That innovation kind of jumps in there and it kind of helps underpin that longevity of the tool. Tool needs to be reliable, needs to be able to perform, needs to be scalable. Won't really dive into these too much right now for the sake of time, but kind of the underpinnings of a tool's longevity can kind of be summed up into these kind of 6 different points over here. What considerations should you have when adopting a new tool? As a data engineer, primarily kind of focusing on startups right now, you can kind of pick tools left and right because the excitement is there. Do I want to take this tool and use it? Can it solve this problem for me? I want to take this in. I want to adopt Databricks. I want to adopt Snowflake. But when should you adopt it? When should you take on a new tool into your stack? This kind of goes into, is a tool solving a problem, or is it a solution looking for a problem? And that's kind of a question you should ask yourself prior to actually adopting a tool. Is this something that I actually need, or is it something that's kind of just a flavor of the day that I think is cool, that I want to use, but don't really know exactly how to use it? When assessing a tool, adopting it to your stack, you have to kind of be cognizant of your reliance on it. Especially with a tool that's relatively new to the market, do you want to essentially put your entire kind of backend infrastructure relying on this tool? Because that kind of bears the question is it going to last? Is it kind of in that transitory phase? Will it still be around in a few years? Will that community support still be present? And will it kind of impact you in a negative way if this tool no longer is supported in the future? So that's kind of something to look into there. Buzzwords is a kind of a big thing here that kind of impacts that. Anyone here heard of data mesh before? It's kind of the current hyped up word, I guess, or buzzword regarding data engineering. I personally haven't really looked into it, don't know much about it, but is it something that's going to last? Is it a concept that's going to stay? I actually have no clue. And luck as well is kind of an aspect here when adopting new tools, especially new tools that are kind of causing a disturbance, that are new to the market. Venture capitalists left and right adopt or invest in new tools everywhere. You have a portfolio consisting of dozens of various private equity investments in various companies introducing new tools. Not all of them are going to be winners. Venture capitalists comprised of individuals who have dedicated their careers into analyzing these tools and investing in them get it wrong, and so will you. So that's kind of be cognizant of that. So pivoting from adopting tools, let's kind of look at the tools that are important in data pipeline development. So how do you make them? What makes them good? So to kind of take a step back, there's a distinction here between code and no-code data pipelines. So no-code in general, drag and drop, doesn't really involve you having to actually code things, has its perks, has its drawbacks listed over here. Code involves writing custom code to develop these data pipelines, such as Python being an example here, using Apache Airflow, using Prefect, so forth and so on. So I'll be focusing on the code aspect here, not so much the no code. So what are the big three? You have Apache Airflow, created back in 2014, 2015 at Airbnb, kind of used as the current king, I guess, of data orchestration. Python-based, you're able to kind of use various operators, integrate them with various tools that you're using, orchestrate data, move data from point A to point B. Prefect has come along from some previous Airflow engineers developing Prefect, and then you have Dagster. So I'll kind of focus more on Airflow and Prefect as they're the ones I've used in production, less so Dagster. So what is Airflow? What is Prefect? They're both data orchestration tools, not to be confused with ETL pipeline tools. So data orchestration and ETL pipeline development are kind of two similar but yet different things. I have data from a data source, going to apply transformations to this data, and then going to move this data from one, let's say, table to another table, working with pandas data frames, transforming it, orchestrating that, and kind of just actually changing this data on the spot using a tool. That's not so much a data orchestration's job. So Apache Airflow kind of speaks to the tools that do that transformation and coordinates with them. And that's what data orchestration is. It's invoking various tools to do specific jobs for you, not so much changing the data itself. And that's what Apache Airflow really does. It's a data orchestrator first and foremost. It's really powerful, especially if you're using it for, if you have a large tech stack. Airflow is able to kind of integrate with many different tools, left and right, using various operators, which are kind of, condensed connectors, I guess. Python connectors you can kind of speak and integrate with Azure, AWS, so forth and so on. Prefect is kind of an orchestrator and also an ETL tool. Essentially, it's Python function wrappers that you're kind of able to invoke various Python functions in kind of a linear fashion and use that to kind of orchestrate your data. I can definitely dive into this more later because I definitely know the explanations are a little bit ambiguous for the sake of time, but yeah. So what is it to become a data engineer? What is it to start your career as a data engineer? So you have technologies and techniques. So languages, kind of the focal point of data engineering, Python and SQL kind of being the most important here. These are tools that are here to stay. Kind of touching back upon that topic of tools that are here, tools that are kind of incumbent within the industry. Even Java's been here forever. Scala is incredibly important as well. Focusing on building your knowledge in these languages is kind of that first step, I guess, to becoming an effective data engineer. When it comes to data orchestration, Airflow, Prefect, and to a lesser extent Dagster as well, have been here for a relatively short time compared to many other tools, but they are the kind of de facto backbone of what is to be data engineering. Containerization is also a very important aspect with Docker and Kubernetes, and data modeling as well is kind of another important technique with data engineering, where you're repackaging API data into the appropriate data model, normalizing data, and so forth. These are kind of the concepts of database development and in turn data engineering. And that's my presentation. And yeah, thank you. Definitely putting up a bit of a sweat here as well, man. It's toasty. But yeah, does anyone here have any questions? Yeah.
Thank you. Yeah, great presentation. So, yeah, quick question regarding in general, you were talking about longevity or kind of how long a model can stay in the market, right? Just wondering if there is any tool right now that kind of, or about any tool that can maybe help us to kind of predict that in some way in the market or not, right? So, and then you were talking about exactly this slide. You have a specific way for each of those, right? Kind of which of those kind of aspect is more important than the other one. And I'm just wondering about also financial perspective or market perspective, maybe to kind of what happened right now in the Silicon Valley that could be affect any potential tool, right? Maybe not be as long in the market because of financial perspective, right? So, thank you.
Yeah, so I guess kind of answer your first question. So, was there a tool that kind of helps you assess another tool's ability to, I guess kind of paint you a better picture to see if a tool will actually lasts?
Right.
At least from my experience, I haven't come across any tool that really does that to a sense, but kind of like applying, especially the first aspect here, the community support component when it comes to yourself assessing tools, especially many of the newer tools that are around right now, primarily ones that are focused on kind of the open source aspect. You're able to kind of easily see how large a community that tool actually has. Prefect, Airflow, Dagster are all open source tools. Hydra, that company that I'm working at right now, is focused on open source. Kind of the ability to be able to kind of go into that repository, see how active the community is pertaining to that tool, I think helps a lot with kind of initially assessing that tool. Sorry, your second question as well. How?
It was about, yeah, exactly this slide. So which of those, if you have a kind of specific way, kind of which of those are kind of more important in terms of, okay, flexibility is more important than performance, right?
Yeah.
And then I was wondering if any of those kind of aspects you have incorporated, or does it kind of include the financial perspective that, let's say that it's a company who has financial issues, or there's any kind of financial issue in the market, like the one that is going on right now in the Silicon Valley, that would be affect longevity or kind of a performance in the time of any specific tool, right? So, like a startup against like a tool from a startup against like a Microsoft or AWS, right?
That's a great question, actually. I may actually think about that question, but we can chat after this. Yeah, that's cool. You're welcome.
Awesome, thank you.
Sue?
So I have a question. Like, when I learned data engineering stuff, they mostly found like open source technology, like Kafka, like Spark.
Yeah.
Like, but they didn't really push like learning how to do it on AWS specifically or GCP or whatever. Like, they were like the basics, the cron jobs, like the bare basics. Like, when do you think like you should start like getting specialized into like a certain cloud, or maybe that's like later down the line?
I think a large aspect of data engineering, in a sense, like you're developing these pipelines, you have to kind of ask yourself, how scalable are they? Spinning up, various Docker containers, or having kind of infrastructure regarding Airflow, Prefect, running on, let's say, on Kubernetes. The cloud component of that helps a lot, I think, when it comes to being able to kind of scale up your operations. So it's kind of that mix of like, you're right, you can kind of do everything locally, have everything kind of running without utilizing any kind of cloud provider. But the kind of bears the question is, how scalable is it in the long run and medium run, within the company? So it's kind of like you're, in a sense, not forced to adopt a cloud provider, but to a large degree, it feels like you kind of are, because you need to be able to kind of accommodate for potential growth within your operations in the future. So that kind of makes sense. Yeah. Cool. Yeah.
First of all, thank you for the presentation. So my question is regarding what are the main challenges of building this data pipeline that you can explain to us? What's the main challenges as data engineering?
There is no right formula, I think, is the biggest one, and that's kind of what I faced throughout my kind of work in the engineering. There is no right pipeline. You can say pulling data from an API source, transforming it in Python into pandas data frames, connecting that to a Postgres database and uploading that data into there, and then maybe creating like an API for that database you can link up to a product. It can be like a ABC kind of standard data engineering project. But in the real life, you don't really get that kind of opportunity. Like there is no right way to address a data engineering problem. Like it's every kind of data source changes, every kind of like transformation changes. Whether or not you have to invoke a machine learning model halfway through and feed it data and take that data as an output. I think the biggest challenge is that there is no formula to develop a standard pipeline. I guess there is no standardized pipeline in the sense that, yeah. So, yeah.
Just a quick question. Can you help me draw a line between a data analyst and an engineer? Are the engineers more just focused on managing resource on cloud, and then what part of your job is more like, are you more focused on that aspect or the analytical aspect using SQL and Python?
So I would say, to kind of touch upon the first part, is a data analyst is there data analyst, I guess, yeah, right, has like many kind of tasks in a sense. But I think it kind of boils down to data analyst using data to derive insights and pulling or creating information based on this data. So I guess kind of how does the data get there? How does the data populate? How is data populated into the database that the data analyst is using? So data engineer is kind of like a support, I guess, in a sense, getting the data there, transforming it, cleaning it up, and presenting it to the data analyst or data scientist or anyone else who may be using this data. So a data analyst uses the data to derive insights, where a data engineer helps kind of provide that data to the data analyst. That's kind of that distinction between the two, I guess, in my opinion. So.
I'm curious if you could kind of speak to your kind of, like if you started out in data engineering and if you didn't, like what were some of the skills that you kind of learned along the way that helped you kind of pave your way into data engineering? Like was it courses, was it a project? Like what was kind of the natural evolution for you into sort of this field?
Good question. I've had like a very non-traditional approach, like 5 years investment, started pursuing a master's in data science, which is not data engineering. Data science, focusing more on the statistical side of things. Data engineering kind of just came to be when I think just like more of a passion towards the software engineering side, or like the strictly kind of coding aspect of things. So kind of looking at a role akin to data science, but kind of involved me being more interactively using various tools to kind of just code and develop these pipelines. I guess that kind of makes sense. It's just more kind of hands-on approach there, where less kind of making sense of the data, but more so actually kind of strictly just coding and getting data there. That's a good question, but I guess that was kind of my train of thought. It was like it's a very ambiguous train of thought, I guess. I'm thinking of it right now, but yeah, that's.
Thank you.
You're welcome. Yeah.
You explanation earlier, so does it mean like data engineer has a lot of similarities with data scientist?
Yes, no, I think it's the data scientist kind of plays the same role as a data analyst. So like a data scientist uses the data as well to kind of apply statistical analysis to this data and drive insights and potential predictions, I guess, of the future landscape of this data. Data scientists kind of doing the forward kind of looking aspect, I guess, of working with this data. In order for a data scientist to actually do their job, the data has to be there, has to be clean, has to be organized in a sense. And data engineer, kind of in its rawest form, is getting the data there into that database for the data scientist to use. So you kind of think of like a data engineer being at the center, providing that data. Then you have data analysts, data scientists, machine learning engineers all using this data, and being that data being supplied by the data engineer. So.
Thank you, Chris.
Welcome.
Do you have any recommendations for no-code data orchestration?
From my personal experience, I've used Data Factory or Zero Data Factory, and Databricks. Databricks is, I guess, like scheduling functionality. So those, I guess, can be both kind of no-code solutions to the orchestration. Zero Data Factory kind of being a click and drop, creating kind of the pipeline itself by dragging these kind of nodes and having, I guess, specific functions for each of these kind of nodes. And that can be, I think, a through and through perfect example of a data engineering kind of no-code solution, where you don't actually have to worry about spinning up the infrastructure and creating the code for Airflow or Prefect to create this pipeline. Databricks kind of offers the same thing. You have a Databricks sheet, and then being able to kind of schedule Databricks jobs which run these sheets. That can kind of be another no-code solution. You still have to write the code for the actual Databricks worksheets, but you're able to kind of orchestrate them without needing to write the code for the orchestrator. So, yeah. How are we for time, by the way?
It's time for coffee.
Yeah? Okay, cool. Awesome. Thank you, everyone.